Which ordered pair is a solution to 3x minus y equals 7? How do I know if this ordered pair will be a solution to the problem? I have x and I have y. What could I do with the x and the y? We're going to substitute it in. We have 3 times my x minus my y equals 7. So my x is 3, my y is 4. We need to simplify. 3 times 3 is 9, and 9 minus 4 equals 5. Does 5 equal 7? No. Then that is not a solution. Next one, 3 times my x, and then I have a negative 4 here. So I already have a minus sign, but now I have a negative 4. Double negatives. 3 times 1 is 3, and negative times a negative is a positive. Meaning up those double signs. 3 plus 4 is 7, and we get that 7 equals 7. That is a solution. Problem C, 3 times my x minus my y. Our x is 5, and again, our y is a negative number, so those are double negatives, negative 3. 3 times 5 is 15. If I clean up these double negatives, we have 15 plus 3 is 18, and 18 does not equal 7. Last one, 3 times my x minus my y, again, double negatives, equals 7. 3 times negative 1 is negative 3, plus 2, does that equal 7? Negative 1 does not equal 7. So B is the only one that is a solution to the equation. Example 2, given the equation, solve for y and make a table. If we look back at our previous section, we can see that when we're using a table of values, the y was by itself. It was very easy to select my x's and simplify for the y. We're going to do the same thing here. So the first step is to solve for y. Well, what's being done to y? It's being added by a negative 2x. How would I put the 2x on the other side of the equation? I'm going to add 2x to this side of the equation, and I'm going to add 2x to this side of the equation. This cancels, and that leaves a positive y equals, I'm going to put my 2x first, and then my negative 3. We're going to put that right here. Y equals 2x minus 3. Now we need to make a table of values and graph. They did not tell us what domain numbers to choose, so we get to choose our own domain numbers. You should choose at least 3. That way you'll know if one of your numbers is off. If you only pick 2, then you'll have no idea whether or not those 2 are accurate. But if I pick at least 3 and one of them is wrong, I will see it when I'm trying to graph it. Let's go with -2, -1, 0, 1. Going to substitute those x values in. I tried to choose numbers that are on both sides of 0, not just all positive numbers. And now we're going to simplify. 2 times -2 is -4, -3. That would be -7. 2 times -1 is -2, and then we have -3, -5. 2 times 0 is 0, minus 3 is -3. 2 times 1 is 2, minus 3 is -1. Now that we have our x's and our y values, we can write them as in ordered pairs. -2 for x, -7 for y. Now that I have some ordered pairs, I'm ready to graph. I see that my largest number on the axis is going to be 7. So I'm just going to label all of these going up to 6 by 2's. You have to put numbers on your graph. If I did not give you a graph that has numbers, you need to have something on there. Otherwise, you will get points taken off. All right, we are ready to plot our points. -2, -7. -2, there's 6 and one more. -1, -5, -1, -5, 0, -3, and 1, -1. This time I am going to connect the dots and make a line. It didn't say for a specific domain, it just said graph the equation. The line extends past these coordinates that I found, these ordered pairs. I'm not just going to stop my line at those points. It goes to infinity on both ends. The domain of this function is about the x. What is the domain? If I run my pencil along the x-axis, is there any place that this function will not exist? If I go to 2, where's the function? Right here. If I go to 6, where's the function? Well, it's going out to infinity, so it will be there at 6. If I'm at 100, would the line still be there? Yes. What about on the negative side? At -4, here's the line. At -10, it would still meet the line. There's no place in the domain that this line is not going to exist. You would say that the domain is all the reals. What about the range? The range is about the y value. So if I take my pencil or pen and I look at the y-axis, is the function there? If I look at 2, here's the function. If I look at 5, here's the function. What about at 10? Would the function still be there? Yes, because this line extends into infinity. Same would be true on the negative side. At -2, is the function there? Yes, it's right here. At -10, would the function be there? Yes, because it's going out to infinity and that line would meet it. So again, the range is all the reals. Standard form of an equation is ax plus by equals c. That is standard form. Standard form. Notice that your x and your y are on the same side of the equation. It says that a, b, and c are real numbers. So that a is a number, b is a number, and c is a number. Standard form means that x and y are together on the same side of the equation, x first, x is positive, and the constant is on the other side of the equation. Graph the function y equals -1/2 x plus 4 with a domain that is greater than or equal to 0. Then identify the range. So here they're giving us what the domain needs to be, what x needs to be. X needs to be greater than or equal to 0. So it can be 0. I'm going to start with 0 and then go 1, 2, 3. That would be a domain that is greater than or equal to 0. And we're going to do the same thing that we just did. Now, I just noticed that we had a fraction here. Unless I like working with fractions, and I should go back and rethink about my domain numbers. My fraction has a denominator of 2. If I choose 1 times a half, well, nothing's going to cancel, or even 3. 3 times a half is 3/2. And adding that to a whole number, I could make my life a little bit easier if I chose some different numbers here. So I'm going to choose numbers that will cancel with the denominator of 2. I'm going to choose 2 because that will divide evenly with the 2. I'm going to choose 4, and I'm going to choose 6. Those are all numbers that will cancel very nicely with this denominator. We have y equals a -1/2 x plus 4. Substituting in 0, 2, 4, and 6. All right. A -1/2 times 0 is 0. And 0 plus 4 is 4. A half times 2. So if I make this a fraction, I can cancel my 2's. What am I left with? Negative, this is going to be 1. So we have -1 times 1 is -1. And 1 times 1 is 1. I could put it over 1, but the goal here was to get rid of fractions. So -1 over 1 is just -1 plus 4. Negative half times 4. Create my fraction, do some cross canceling. I can divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Negative 1 times 2 is negative 2 plus 4. Make my 6 a fraction. Cross cancel. 2 divided by 2 is 1. 6 divided by 2 is 3. And we get negative 1 times 3. It's negative 3 plus 4. And now I'm ready to create my ordered pairs. 0 for x, 4 for y. All right, my largest number is 6. So I'll go out to 6 on all the axes again. All right, 0, 0, 4, 2, 3, x is 2, y is 3, 4, 2, and 6, 1. Again, the domain is greater than 0, so I'm not going to create that line that comes over here because the domain would then be in the negatives. So I need to start where the domain is 0 and go forward. And I would draw an arrow on the other end of the line because it says the domain is greater than 0. Then identify the range. Okay. What is the range here? If I take my pen and I run it along the y-axis, is the function going to be up here at 7? No, I don't see the function anywhere here. At 7, 8, do I see it at 6? No, 5. Where does it start? The range starts at 4. Then what does it do? It goes down to 3, down to 2, down to 1. Any fractions that are in between there would be there. And it continues to negative infinity. So how would I describe this? Well, where's the range? The range is greater than 4, less than 4. The range is less than 4. Is it equal to 4 as well? Yes, it's right at 4. So we would say that y, because it's the range, the y has to be less than or equal to 4. That would be the range. Example 4. The distance d in miles that a runner travels is given by the function d equals 6t, where t is the time in hours spent running. The runner plans to go for a 1.5-hour run. Graph the function and identify the domain and range. What do we know? We have an equation. We have that d equals 6t. Which variable is the independent variable? Because the independent variable goes over here. The dependent variable would go on this side. So t, time, and distance is dependent upon the time. We know that, let's see, a 1.5-hour run. So we could say at time, about a half hour, an hour, 1.5 hours. We could also say it's 0 hours, really, 0. Okay, so we have d equals 6 times t. Six times 0.5. 6 times 5 is 30 with 1 decimal place. 6 times 1 is 6. 6 times 1.5. 6 times 1.5. 9. And then 6 times 0 is 0. Okay. We have that this is the time. This is the distance. And we're going to plot our points. 0.5, 3. So at 0.5, the distance was 3 miles. At 1 hour, it go 6 miles. At 1.5 hours, you could go 9. And at 0 hours, you didn't go anywhere. You're still at 0. Graph the function and identifies domain and range. So the domain is between 0 and 1.5. The domain only goes from 0 to 1.5. Doesn't go to 2. So you could say that t has to be greater than and equal to 0, because it starts at 0. Then it has to be less than and equal to 1.5. The range, which is about the distance, the range would have to be, the distance has to be greater than or equal to 0 and less than or equal to 9. The range is going from 0 to